Welcome to this episode of AI Talk. Today we're diving into one of the most intriguing and complex optimization challenges known in mathematics, the Chinese Postman Problem. This problem isn't just a theoretical puzzle, it's a critical issue that influences how we plan routes in urban logistics, affecting everything from postal deliveries to garbage collection. The core of this problem lies in finding the most efficient route that allows a postman to traverse every street in a neighborhood exactly once and return to the starting point. In this episode, we'll explore how neural networks and cutting-edge technologies like quantum computing are being leveraged to solve this challenge. Whether you're into AI, math, or just curious about how these advanced tools are shaping our world, this discussion is for you. So let's get started. To truly appreciate the significance of the Chinese Postman Problem, we need to take a step back and explore its origins and theoretical foundation. This problem was first introduced by the Chinese mathematician Meiko Quan in the early 1960s. It's based on the concept of Eulerian paths and cycles, which were originally studied by the famous mathematician Leonhard Euler in the 18th century. An Eulerian path is a trail in a graph that visits every edge exactly once, and an Eulerian cycle is a path that starts and ends at the same vertex. The Chinese Postman Problem asks whether it's possible to construct such a path or cycle in a given network of streets, and if so, what the shortest possible route would be. Graph theory and optimization, making it both fascinating and incredibly complex. Now that we understand the history and theoretical foundation of the Chinese Postman Problem, let's discuss how neural networks can be employed to tackle this challenge. Neural networks, particularly graph neural networks and recurrent neural networks, have shown great potential in solving complex optimization problems. Graph neural networks are designed to operate on graph data structures, which makes them particularly suitable for this problem. They can analyze the relationships between nodes, or in our case, street intersections and edges, which represent the streets themselves. By training these networks on various routing scenarios, we can develop models that predict the most efficient paths for traversing a network. Additionally, recurrent neural networks, known for their strength in processing sequential data, can also be adapted to this problem. They can help in developing strategies for route planning by considering the order in which streets should be visited based on previously encountered data. Together, these neural network architectures offer a powerful toolkit for finding optimal solutions to the Chinese Postman Problem. Let's look at some real-life examples. Logistics companies around the world face the challenge of optimizing delivery routes to minimize costs and time. For instance, major delivery services like UPS and FedEx use advanced algorithms that are inspired by the principles of the Chinese Postman Problem. By employing machine learning techniques, including neural networks, they can analyze vast amounts of data related to traffic patterns, delivery times, and customer locations. This analysis helps them to determine the most efficient routes for their delivery trucks, ensuring that every package reaches its destination promptly. By applying these advanced optimization methods, they can create schedules that not only save time and resources, but also reduce their carbon footprint. These examples highlight how theoretical problems can be transformed into practical solutions through the innovative use of artificial intelligence. As we explore the intersection of neural networks and the Chinese Postman Problem, it's essential to highlight the current research and developments in this area. Numerous academic studies and papers have been published focusing on optimizing routing problems using machine learning and artificial intelligence techniques. Researchers are actively working on enhancing the capabilities of neural networks to improve their performance in solving complex routing tasks. For example, studies have demonstrated that combining reinforcement learning with graph neural networks can yield more efficient solutions by allowing the model to learn from trial and error, mimicking how a human might navigate a network. Moreover, advancements in quantum computing have opened new avenues for tackling this problem. Some researchers are investigating how quantum algorithms can complement neural networks, offering the potential for solving even larger and more complex instances of the Chinese Postman Problem faster than traditional methods. This ongoing research not only enriches our understanding of optimization, but also paves the way for innovative applications in various industries. Looking ahead, the future of solving the Chinese Postman Problem with neural networks and advanced technologies is promising. As computational power continues to grow, we can expect even more sophisticated models capable of addressing larger and more complex routing challenges. One exciting prospect is the integration of real-time data into these optimization processes. For instance, incorporating live traffic updates and environmental conditions can allow neural networks to adjust routes dynamically, improving efficiency and response times for logistics and emergency services alike. Additionally, as research progresses, we might see more interdisciplinary approaches that combine insights from mathematics, computer science, and operations research. These collaborations could lead to the development of novel algorithms that not only solve the Chinese postman problem more effectively, but also adapt to the unique requirements of different industries. In summary, the marriage of neural networks, quantum computing, and real-world applications promises to revolutionize how we approach routing problems, making our cities more efficient and sustainable. As we wrap up today's discussion on the Chinese postman problem and the role of neural networks in solving it, I want to emphasize the importance of this topic. Understanding how advanced technologies can optimize real-world challenges not only enhances our knowledge of mathematics and AI, but also opens up exciting opportunities for innovation across various sectors. I invite you to reflect on the insights we've shared today. How do you see the role of artificial intelligence evolving in your daily life or industry? What are your thoughts on the potential of neural networks in tackling complex problems? Don't forget to subscribe to our podcast and click the notification bell so you never miss an episode. And as a special treat, be sure to listen to the melody generated by artificial intelligence that connects to our podcast theme. Thank you for joining us on this journey through the fascinating world of optimization and AI.
Searching for the path, this journey never ends. Neural nets they guide through winding roads and bends. Data streams collide in this labyrinth of lines. Algorithms light, spark and code divine. Chinese postman rides through the circuit maze, solving every node in futuristic blaze. Dynamic networks hum with patterns deeply sewn. Machine minds at play, unlocking the unknown. Graphs and arcs reveal a tale of every turn. Neural webs they feel where probabilities burn. Chinese postman rides through the circuit maze, solving every node in futuristic blaze.
Where the future is now. Today let the rhythm of progress lead you somehow. Imagine the soundscape that pulses innovation, a melody that defies all limitation. We're breaking barriers, we're pushing the line, exploring new frontiers.